Ethereum has evolved a lot over the years. Today, it secures hundreds of billions of dollars, processes countless transactions, and powers thousands of decentralized apps. So here's a simple, updated look at what it is and how it works. But to understand Ethereum, we first need a refresher on Bitcoin. Bitcoin introduced the world to blockchain technology, a shared, globally distributed ledger that no single person controlled. This allowed it to function as a secure, censorship-resistant currency open for anyone to use. Ethereum, launched in 2015 by Vitalik Buterin, wanted to expand on that idea by making the blockchain programmable. Instead of just keeping track of who owns what if the network itself could run code? Think of it like a cloud computer, open to anyone, owned by no one, and designed to keep running even if its original creator disappeared. To make that possible, Ethereum introduced something new: smart contracts. They're pieces of code deployed on the blockchain that automatically do whatever they're programmed to do without humans in the middle. If a contract says, "Send this token when that condition is met," it happens exactly as written. This is what makes decentralized apps, dApps, possible. Everything from NFT marketplaces and mini-games to lending protocols, exchanges, and prediction markets. Of course, all of this computation doesn't just run for free. That's where ETH, Ethereum's native currency, comes in. Whenever someone interacts with the network, whether to move funds, swap tokens on a decentralized exchange, or deploy a smart contract, some ETH is required as gas, a payment to the network. Most of it gets burnt, which helps prevent spam. Burning ETH also reduces the total supply, making ETH deflationary when the network is busy. And the rest goes to the people who keep Ethereum running smoothly. Similar to how Bitcoin has miners, the Ethereum network too has thousands of nodes running its software. A portion of these nodes act as validators, which have the responsibility of verifying transactions and agreeing on the final order in which they're added to the chain. To become a validator, a node operator has to stake ETH, locking it up like a security deposit for good behavior. In return, they earn more ETH as a reward, which is also how new ETH enters circulation. If they misbehave, they can lose their staked ETH. This system of reaching an agreement is aptly named proof of stake. But before 2022, Ethereum used to rely on the same system as Bitcoin, proof of work, which required some serious computing power. There are pros and cons to each method, but one result of the switch is that Ethereum's energy use was slashed by roughly 99%. That's just one of the ways Ethereum has evolved over the years. Ethereum was also infamously expensive to use, with transaction fees skyrocketing during busy periods. To scale the network and support more users, Ethereum now primarily relies on something called Layer 2s. These are separate networks built on top of Ethereum to improve speed and lower costs. They handle most of the activity before bundling and settling in on Ethereum for security. All that said though, Ethereum certainly isn't perfect. Fees can still spike, user experience is often clunky, and staking remains somewhat concentrated, with a handful of large providers running a big portion of validators. But Ethereum hasn't stopped evolving, and has an ongoing roadmap stretching into the next decade. Continuous evolution is part of its design. We won't dive into the technical details, but in essence, the goal is to make the network cheaper, faster, and easier to use, all while keeping it as secure and decentralized as possible. Of course, reality is always more complicated than the ideal. Learn more about the current nuances of decentralized apps in this video next.